Hi everyone, my name is Justus Ortlepp. I am the product manager for Tazama, a real-time open source transaction monitoring system. We have been in the Linux Foundation since December 2023. We've been funded by the Bill and Melinda Gates Foundation since 2019, and we joined the Digital Public Goods Alliance about 2 months ago. So we are very happy to be here. Sadly, Greg could not make it today. He was my co-presenter. Greg is currently resolving the devastation of Hurricane Milton in Florida, where he lives. So he sends his regards and his apologies. That leaves me to do the hard part of the presentation, which is all the introductory stuff, and not just the product. So Tazama is a Swahili word, which means to look or to watch, and to inspect, to investigate and examine. And it is the perfect word for our system and for the work that we do. We look at transactions and we evaluate them for fraud and money laundering behaviors. Somewhere on this picture, if you were here last night, you would know that we spoke about the line that is hidden in this picture. So far, only 2 people have found it, and for us, it's a perfect analogy for what fraud actually looks like in your environments if you don't have the tools or the skills or the abilities to try and find it. It's in there, it is waiting to prey on your transactions and your participants, and that is something that we want to be able to prevent and avoid. Fraud is a known problem worldwide. We look at Kenya, for example, lost 4.5% of their GDP to scams. 40% of all fraud is scam fraud. 25.5% of the global population is defrauded, and it amounts to over $1 trillion in losses for organizations and individuals. No one doubts the negative impact of fraud. I'm pretty sure everybody in this room knows somebody who has fallen victim to a fraud or a scam of some kind. It is not a problem that is new to any of us, and it's something that we always have to be on the lookout for. We are, as I mentioned, an open source software transaction monitoring tool. We detect fraud, and we also do money laundering detection as a supporting mechanism to assist us in the detection of fraud. We've been funded by the Bill and Melinda Gates Foundation for the last 5 years, since they originated the project, and we joined the Linux Foundation recently. Many of you may be familiar with Mojaloop. So Mojaloop was the original sort of idea where Tazama came from, but we eventually ended up joining the Linux Foundation to give us a slightly broader and more global scope for transaction monitoring beyond just a Mojaloop implementation, although our system is still very much linked to Mojaloop as a sister project. The project itself is managed by the original 3 participants in Tazama as it exists today, which is myself as the product manager, Greg McCormick, who is our executive director, and Rekha Ramprasad, who is also here today. She is our subject matter expert for ethics, compliance, regulatory matters, and has deep experience in that area. Our geographical focus is largely and primarily in Africa as our first phase. This is the territory that we are looking at first and foremost, and our mission is based on financial inclusion principles. So we want to look at how can we create safer and more secure transacting environments to encourage people to join digital financial ecosystems where they do not necessarily have the trust that those systems are safe, because people are unfamiliar with the way that digital ecosystems might work. Beyond Africa, also Southeast Asia is a target territory, and we've already started speaking to a number of organizations in that territory to bring Tazama to a wider audience. And then even in Latin America, I saw that there was a presentation earlier where Mojaloop had, I think through some of our partners in that area, also started to do implementations, and we would hope that Tazama would follow as a means to detect and prevent fraud. Our mission is building trust. We can help stop fraud before it happens. That is our goal, and ultimately, you have to be able to prevent the fraud in the first place, because it's almost impossible to get that money back once the money has changed hands. So we want to be quick, and we want to be able to intercept the transactions before the transaction is concluded. Many similar systems focus on fraud detection after the fact, or even money laundering detection. So we look at data warehousing solutions that mines all of the data for the transactions that had already concluded on sort of a day-late basis or end-of-day kind of basis. We want to be able to intercept every transaction, monitor and evaluate that transaction as it is performed, and make a decision about whether that transaction is suspicious or safe. Trust is critical to promote the use of digital payment systems in financial ecosystems, and digital payment systems are critical to promote financial inclusion. Studies have shown, and that is also the mission that has been imparted to us by our funders. The Tazama journey. So we started originally as an idea back in 2016 alongside Mojaloop as one of the Bill and Melinda Gates Foundation's Level 1 project principles. The Mojaloop for a shared transaction monitoring switching platform that is interoperable, and then our pillar, which was for shared investment and fraud detection, so that that switching operation itself can be safe. The Bill and Melinda Gates Foundation approached Deloitte here in South Africa in 2019 and commissioned the development of a requirement specification and also a study on instant payments fraud in emerging economies and in economies in general. Out of that, we delivered the requirement specification, and the project was ratified by the Mojaloop community at the time. And then we started doing a build through a local partner here in South Africa called Cybrin, and also Lextago, who you would have met if you had met Rob. Rob was involved in the original build of the project as well. And they built the minimum viable product over about 15 months. We delivered that in 2022 in April. And we went live with a number of default typologies and rules so that the system can be effective at detecting fraud out of the box. We had our first convening in Jordan, and we sorely miss our Jordanian colleagues from JOPAC, who were instrumental in that initial session on making us feel welcome and helping us to also understand their specific requirements in their environment, alongside BankServe, who I was also very happy to see here. So Sarah also joined us in JOPAC in Jordan when we had our first convening. And since then, we embarked on a period of beta testing with both BankServe and with JOPAC to illustrate the benefits of the system and also to be able to refine our approaches and to be able to pick some of the features that they needed for the solution and add that to the platform itself as well. And then we joined the Linux Foundation in December of last year, and that was almost sort of felt like a big step up for us onto the global stage. We spent the first part of this year resolving some of our governance challenges to make the product a Linux product, true at its core, and we released version 2 of the system in July of this year. And then, as I mentioned 2 months ago, we joined the Digital Public Goods Alliance, and we were very privileged to join the Digital Public Infrastructure Summit in Egypt, which was just a couple of weeks ago. And it was great to be part of that community as well, where there are so many products now out there trying to make the world a better place. And it is an illustrious group of peers that we find ourselves amongst. And then we have another release coming up in November, so you can look forward to the system constantly improving. I've mentioned the real-time aspect of the system already. So for us, that is an extremely important part of the system. You have to look at the transactions as they happen so that you can stop the fraud before the transaction is completed. The system is also API-driven. For us, that is essential because you want to be able to provide fraud detection as a service, not just to a single operator, but perhaps on a much wider scale at a switch level or at a financial regulator level or at a central bank level. So the best way to achieve that is without having to integrate with a variety of different systems on a point-to-point basis. An API allows people to bring the transaction to you, and then you can then do the evaluation in real time and then give them a response about whether or not that transaction is suspicious. Our system is deliberately rules-based, which might seem a little bit quaint in the modern age of AI and machine learning, but that is a decision that we made to make the system as accessible as possible in the environment that we want to operate. It is very difficult and expensive sometimes for people in our target territories to be able to create the machine learning models and manage and maintain those models over time with very expensive resources that they typically have to import from somewhere else. We wanted the system to be out of the box, ready to run, and detect fraud from the first day. So in a greenfield environment where you may not have an existing transaction monitoring solution, a rules-based system is still your best bet. You don't need deep data to be able to train it. The system can be up and running as soon as you are able to turn it on. And following on with the theme, for an accessible environment, the system itself must be configurable through an external user interface that we can then change the behavior and the detection capabilities of the rules and the scenarios that we have, so that you don't need a on-staff development team to change code. You can have your fraud analysts and your investigators actually change the parameters according to which rules are detected, based on your feedback that you're getting from the system. In its context, the system effectively listens to transactions that are sent to it from a transaction system. Our system interface is built in ISO 20022. Mostly we wanted to be able to follow a standard that is growing and widely adopted elsewhere in the world. But if you don't have the ISO 20022 capabilities yet, you can implement a payment platform adapter. We built an existing payment platform adapter for Mojaloop, mostly because of our long association with Mojaloop now. So if you are a Mojaloop implementation, you can use the payment platform adapter to automatically connect to Tazama, and from Tazama, you'll be able to get responses about the fraud and suspicious transactions in your ecosystem. From there, alerts would go to a case management and investigation management system. In our early engagements through our beta testing, we learned that people don't just want an engine for fraud detection, they want a complete package. Our initial assumption about case management systems being pervasive and available everywhere was incorrect, and we now have to also add case and investigation management capabilities to the system as a native component. We are working with Kumisa, who is going to be implementing Tazama for their Mojaloop cross-border merchant payments platform, to build the case and investigation management as part of that project, and that will then become part of the open source that will be available to everybody else as well. You can download the software now, and you can deploy it in your own environment and operate it for yourself. The software works, it is available. What we also typically find is people would want to work through a system integrator that can deploy the software for you, and that you can also then hand off the maintenance and support tasks for all of the technical stuff, but the responsibility for investigating fraud alerts and managing fraud in your ecosystem will still be your own. If you are a switch, you can accept transactions on behalf of your entire ecosystem. We often find that wherever you look for fraud in your transactions, the blind spot that you have is everything that exists outside of your network. Switches, regulators, and central banks are extremely well placed to be able to detect fraud across the entire ecosystem, because they can demand a view of every transaction in an ecosystem. We see that in the Bank of Tanzania, for example, with TIPS. They want to be able to see every transaction that is performed in the network, even if that transaction is internal to a bank only. The transactions must be visible and surfaced so that it can be available to everybody to see and evaluate. Similar in Canada. All Canadian transactions are switched through a central system, so you are able to put a transaction monitoring system on that central source, and you won't get a better perspective of fraud and money laundering in your network as at the core. And then finally, we also do see an appetite for people operating the system as a managed service, so you can deploy it as an independent third party adjacent to an ecosystem, and you can monitor all the transactions in that ecosystem on behalf of the ecosystem, even as far as doing investigations and regulatory reporting on behalf of your ecosystem. All of these are possible with Tazama. How the system itself works, and I'm going to go through this very quickly, but if anybody would like a more detailed overview of the system's internal mechanics, please let us know, and we'd be more than happy to do a personal demonstration. But the system absorbs all of the transactions via its transaction monitoring service API and persists those transactions as transaction history. You can't do an evaluation just based on the message that you are looking at now. You have to evaluate that message within the context of the past behavior of the participants. How did the debtor behave up to this point? How did the creditor behave up to this point? So you have to collect that transaction history and store it in your own database so that you can use that for your evaluation purposes. We have a number of rule processors that we have deployed by default into the system. There are 33 rule processors that evaluate all of the transactions coming through the system and then summarizes the results in a number of predefined scenarios. so that an investigator has some idea of where to start with their investigation when they are looking for at a particular alert. And then the system is able to send out 2 levels of alerts. So you can send out a blocking instruction so that the transaction can be blocked immediately, or you could just send out an alert that says the transaction must be investigated. Typically, we want fraud to be evaluated in this area here because the transaction has to be blocked. But if you're purely looking at money laundering behaviors, then you want to look at it in this area in the middle, because very often your regulator doesn't want you to tip off the criminals that you are investigating or that you have identified. They want you to surveil them over a long period of time. So you can also just do what is called sort of a soft alert to say, we want the reporting to happen, but we don't want the transaction to be blocked. In our initial study, we came up with 272 typologies for instant payments, covering a range of behaviors from fraud, money laundering, even some bribery. These typologies were composed into a list out of which we built 30 typologies already based on the data that was immediately available in an ISO 20022 message in the system. And we built the 33 rules, and we can summarize those rules across a number of scenarios. So for example, the money laundering behaviors for placement and for integration and for layering. We can spot account muling in your network. We can spot account takeover, and also simple behaviors like transaction mirroring, where somebody receives money and then immediately pays money out, which is typically a money laundering behavior as well. We made a significant investment in effort in authorized push payments fraud. 40% of all fraud is authorized push payments fraud or scams, where somebody actually allows somebody else to transfer the money. So it's, and very often in the past, you found that the banks would say, well, it's your fault because you transferred the money. So how do we actually prevent people from performing those kinds of transactions? And the way that we would do that is through this particular scam typology. We would evaluate a transaction in real time, look at the behaviors, and then block that transaction. So out of a typical advanced fee fraud kind of scam, or an APP scam, there are a number of behaviors that we can evaluate. We look at the debtor to see how they behaved in their history. Did they behave like a victim, or are they in some way vulnerable to a scam? And we look at the side of the creditor. How had they behaved in the past? Are they a money launderer in particular? Every scammer is eventually a money launderer anyway, so we look for those money laundering behaviors in the creditor's history to identify whether the current transaction might be suspicious. And then we summarize the results out of all of those rules that we identify based on those data points, and then we'll give you an assessment of how suspicious the transaction is and whether or not the transaction itself should be blocked. We have developed, for demonstration purposes, a front end. I'm not going to take you through the steps today, but some of you also saw this last night in our Innovation Expo. You are able to create transactions on this side that gives you some insight into the debtor and the creditor, and you can use this utility to test patterns of fraud and money laundering behavior in your network and see what the results are. But it also creates a visual aspect here for us to understand how rules and typologies are composed. So in a typical situation where you have a duplicate transaction and you have the same transaction being performed between the same two people very quickly in a row, you want the system to respond to the second transaction to say, the second transaction appears suspicious because we have the same creditor in the transaction. We have the same amount of money, more or less, because we can't, I think to your point earlier, you can't evaluate a transaction precisely, so you have to evaluate the transaction within a limit of tolerance. So we don't look for a transaction that is exactly the same. We look for a transaction that has a configurable level of tolerance to say that it is more or less the same as a previous transaction. And then if the transaction has a similar description, or if the transaction has been performed very quickly on top of another transaction, or if the creditor is showing any mirroring behavior in their past history, all of those factors together would roll up into a single typology, which would then say if any of those behaviors or enough of those behaviors triggered, we would stop that transaction from completing. We have, as I mentioned earlier, we have our Tazama 2.0 release that went out in June, and a lot of that was what we called a foundational release. So we wanted to get all of our latent technical debt out of the way and prepare the system as a platform that can then grow faster and start taking on contributions from elsewhere in the community in a more seamless way as part of the Linux Foundation. In this quarter, we started working on our features release. We'll see a lot of those features being delivered in 2011. And in particular, one of the features that more people have asked for is around what we call list management, is the ability to block transactions or to allow transactions. You want to override the behavior of the system in a case where somebody is standing at a merchant and for whatever reason their transaction isn't going through because the system had flagged it as fraud. You want to be able to respond to a customer query like that to say, okay, we'll give you a 5-minute override so that you can at least complete your transaction, and then the system will go back to its normal behavior. And then that will also go for investigation because you want to find out how did the system get it wrong. And then hopefully that wasn't the customer phoning in because the fraud was actually happening and that wasn't the customer. But you'll discover that through your investigation process anyway. But that list management override process and also the blocking mechanism is essential for you to apply operational control over transaction flows in your network with Tazama to assist. We added API security with JWT tokens on our API, so that the API itself is also secured. We use a third-party application called Keycloak to help administer that. But if you wanted to apply your own security system to govern the security, then you can also do that. And then finally, we also made it a little bit easier for messages from the system to be communicated outwards to other systems. So if you wanted to communicate the alert to a REST or a Kafka or a RabbitMQ interface, then you can do that a little bit easier now as well. And then looking forward, we have a number of changes that we are continuously making to the system to keep the system up to date and also to improve the system. So we implemented an ISO 20022 interface in JSON format. And as everybody here would probably know, JSON is not the preferred form of communication for ISO 20022. So we are also working on an XML-based interface just to make the system a little bit more accessible and interoperable for people to use. I'll leave the slide here. I think everybody can look at it later, but the one that I also did want to call out is the case and investigation management here. So that is something that we are working on including now out of the Camisa implementation. And then we also just wanted to quickly pause here to say that working with the Interledger Foundation, we had applied for a grant. We see an opportunity here alongside the Interledger Foundation where some of the products within the Interledger Foundation, such as Open Payments or Rafiki, could benefit from a established and native payment platform adapter so that anybody who uses these protocols or the software can actually integrate into Tazama by default. So if you wanted to apply Tazama as a transaction monitoring system to a Open Payments or a Rafiki implementation, you should be able to do that much easier. And for us, we have applied for a grant, and we hope to be able to build the payment platform adapter that would benefit both the Interledger Foundation and then also Tazama itself in the long run. And then finally, we are an open source product, so how would you like to be able to be involved in an open source product such as ours? You can use our product. It's free. Access it through GitHub, download it, run it in your own environment, explore it, give us any feedback that you might have, things that you might think is missing. And if you have a use case or a implementation that would involve Tazama, please do let us know. And join our community. Our community journey starts in Slack. So we have a Slack that you can also join, and you can speak to us about your questions, and you can ask us to help you with your installation. Hopefully you won't need much help because we've been working really hard on the documentation to make it as easy as possible to deploy. And if you wanted to contribute in a more tangible way, our project is currently funded by the Bill and Melinda Gates Foundation, but we are obviously open to more funding to be able to achieve the goals for financial inclusion in other areas as well. If you want to contribute time and volunteer your time to be able to improve the software or work on the software, that would be most welcome as well. Bring us your problems, your specific use cases for fraud and money laundering, or anything else that you might think Tazama would be useful for, and we will help you solve those problems. And any of your skills and experience in financial services or any of the tools that you would like to integrate with, all of those contributions would be most welcome and put forward towards making digital financial ecosystems safer for everyone. And thank you very much. Thank you also to the Interledger Foundation for inviting us and hosting us. It's really great to be here in Cape Town. Weather has been great, which I understand is sometimes rare. So thank you very much for that as well. Thank you to our sponsors, the Bill and Melinda Gates Foundation, for bringing Tazama to life and to continue to support us in the way that they have. We appreciate it. Thank you very much. If there are any questions, I do have a little bit of time left over, so please.
And we do have mics on both sides. So,
just out of interest, what do you optimize for? The true positive rate of detecting fraud or reducing your false negative rate? And what's the business impact of that? And then secondly, given that it's API driven, do your users, do they share post-transaction feedback after investigations and so forth? Just those are my two questions.
I'll answer the first one first. So we recently worked on a tech sprint with the Financial Conduct Authority in the UK. We'll be presenting our results on that tech sprint on the 4th of November at their Autumn Expo. We were very excited about that as well because they had access to a authorized push payments fraud synthetic data set that they allowed us to work with Tazama, and it was a great learning experience for us on how do you actually make the models work better. And for that project, the two metrics that we came up with are both of the ones that you mentioned. So you want to improve your detection rate while simultaneously maintaining a low false positive rate. If your false positive rate is too high, you're going to overwhelm your investigation teams with the operational need to investigate every single one of those alerts. So we focused on trying to detect all the fraud in the system, but as soon as you make the thresholds too sensitive, then it also alerts every transaction for investigation. And that's too many. If you want to be able to run your system at scale and you are doing 100 transactions a second, you will have to have an enormous team of people doing investigations to make sure that those evaluations are accurate. So we want both of those metrics. We want to make the detection rate high, and we want to make the false positive rate low. And then your second question is, it depends on the implementation in the scheme itself. So typically, if you are doing an investigation on a transaction and you have just saved somebody from making a transaction, you might want to tell them that you blocked the transaction because of suspicious behavior, because otherwise they'll just try again, or they'll try in some other way. Because you'll actually be surprised how determined people are to send somebody money for a fraudulent transaction. And in particular, that's something that makes romance scams so lethal, because the people have bought into that in such an emotional way that they are firmly in the belief that they are sending money to somebody for a legitimate purpose. And you have to sometimes communicate back to your user base to say, the transaction that you are performing now, we have decided is not a safe transaction, and please can we maybe counsel you a little bit through that? Because you do have to give that feedback loop. But in other ways as well, if your investigators are doing investigations and picking up fraud where you have a false positive, you need to close the loop back to your originating system again to say, we are picking up transactions that are not fraud as fraud, so we need to change the way that the models are operating. So you can't just conclude the investigation and leave the transaction. You actually have to close the loop on that transaction. And beyond that, if you're working inside an ecosystem as a switch, for example, your scheme rules will dictate whether or not you have an obligation to inform your partner participants, for example, if you pick up fraud. So if I pick up fraud in some other bank's network, usually the stance is that that is their customer and I have no control over what they do with their customer. I just want to protect my customers. So there has to be a sort of a bilateral agreement to say that if we pick up fraud in your network, we're going to let you know about it because we actually want you to protect the overall safety of the ecosystem and not just one side of it. I hope that answers the question.
Yes, thank you for doing all this work out in the open. There's not enough software that's open source in this industry, so I really appreciate progress in that direction. You sort of touched on what my question was going to be, so I hope it's not redundant here, but you had a slide talking about the impact that fraud has, and you've talked about false positives, but I was curious if you've looked into what impact the false positives are having. Because I think that when we're talking about a context of financial inclusion, somebody might try to use digital financial services, but then get declared as a fraudster, and then everything locks up, and then they get kicked off, and then they get frustrated, and they don't try again. So how do you think about that? Are there any good studies around that? Have you looked into this? And how do you try to be part of the solution in that regard?
So I think false positives shouldn't necessarily impact the account until you've completed the investigation. And your customers often give you very good feedback about their experience with your system. And we expect that feedback even in the system itself. So for example, if your system is missing the fraud that happened, your customer will contact you to let you know that they were defrauded, hopefully. Because you also have to kind of normalize the communication from your customer around fraud so that they don't feel embarrassed and shamed because they were defrauded. You have to treat them as a person whose rights and their privacy and their sense of self was violated in some way, and there needs to be empathy from the organization in how to deal with those kind of things. So if you do pick up fraud, how do you approach the customer to say, well, can we deal with this? Can we resolve this issue? But you should never block an account right up until the point where you have absolutely confirmed that that person was at fault. And you should have a rapid response of some kind to say that if you want to deal with false positives in a way that is impacting somebody, like if you're standing at a merchant, the last thing you want is a false positive result that stops you from making a payment because there's a queue of people building up behind you and now it starts getting embarrassing. Right? People are fidgeting because you are holding up the queue. Nobody wants that situation, so how do you actually resolve that? How do you create a situation where you can manage your risk, but also keep in mind the impact that it has on the people that you're trying to serve? So I think the key for me there is always something like empathy. You have to have empathy with your customers, you have to have empathy with your situation, and balance that with the risk that you're trying to prevent in the first place.
Thank you.
Thank you so much. I think that if there are more questions, you will be around, not running away.
Yes, we are here. We're here all weekend.
Oh, even better. Thanks so much for the presentation.
Thank you very much, and thank you very much, everyone.